Welcome. The title of today's notes is Cryptography, and cryptography just means code breaking. So today we'll be taking a look at using matrices to encode and decode certain messages here. Now, I certainly won't insult your intelligence by saying that this is how true code breaking works, but I guess in a very, very oversimplified way, it would have the same tenets of code breaking. So if I'm trying to send you a message, you basically know how it was encoded, and so when you get that jumbled message, then you have a chance of decoding it. Whereas if the message was intercepted by somebody else who didn't know how it was encoded, really they would have no way to decode it and figure out what it says. So we'll try this out. We're going to go through the process completely together through example 1. I'll have you try one with example 2, and then maybe if you're feeling up to it, we'd love for you to try one long one on example 3, see if you can put it all together. So again, what we're going to do here is take the message boulder, and what we're going to do is basically encode it so we can make it garbled, and then we're going to decode it. And so here's what it says. We're going to do this in 2s, by the way, just FYI. We could do this theoretically in 3s or 4s or anything else, but 2s is where we have our most background and experience with, so we'll do it that way. And so on your paper it does say use the encoding matrix right here, and so we're going to use that piece. Now you notice on my screen I don't have that nice table of letters matching up with numbers, but you have it, and so you'll be able to kind of walk through with me. I at least have it in my hand, and I'll be able to kind of work through some ideas. So here's the premise. What we're going to do initially is take the letters from Boulder, and we're going to assign numerical values to them. So if you go to your table there, it looks like the easiest thing to do is to make the B a 2. Okay, so we're going to go in kind of that primary column right there. The O will be the, let's see, make sure, O is 15. Okay, the U, it looks like, will be 21. The L will be 12. D will be 4. E will be 5. Yep, let me get that again. So the E will be 5, and then the R will be 18. And so what we're going to do basically is take those numbers, and what we're going to try to do is garble them basically. What we're going to do is multiply them into our encoding matrix to change their values. So the way we're going to play this out, everybody, is these two are going to go together, match them up for me. These two are going to go together, match them up for me. These two are going to go together and match them up. And as you see, because there are an odd amount of numbers here, what we need to do is sort of have a space on the back. So I'm going to do Boulder with a space just as a placeholder, and this space let's have as 0. So I can get a pair there just by putting an added placeholder. And in this case, if you look on your table, that space, the easiest thing to do is to make that 0. And so here's what's going to happen. I want to change the 2 and 15 there. And when I change the 2 and 15 to 2 different numbers, then we'll go back and look at our table and see which letters would appear. And so what we're going to do is we're going to do this with matrix multiplication. And we do have to be a little careful here. I'm going to treat these two numbers side by side exactly as you see right here. And I'm going to multiply those with that encoding matrix, the 2 by 2. Now remember what we talked about with matrix multiplication, of course. Order does matter. So I guess I would ask you, this 2 and 15 right here, is it going to the left of our encoding matrix or to the right of our encoding matrix? Think about that for a second. And if you think about this being a 1 by 2, and this a 2 by 1, then that would have to be on the left. And so that's how it's going to play out, everyone. And so I'm going to do a few with you here, of course. So what we're going to do is take that 2 and 15, and we're going to multiply into our encoding matrix. And so I kept the encoding matrix pretty simple, relatively speaking. And let's see what happens. So notice in this case, when I put a little equals on the back, a 1 by 2 times 2 by 2 is a 1 by 2. And so you can see by multiplying into this encoding matrix, I'm not going to change the dimensions. I'm just going to change the values. So let's do this together here. I've got some numbers, and we'll play them out. So remember how matrix multiplication works. We go across the row and down the column in the right. So 2 times 1 plus 15 times 2. 2 plus 30. So 32 is the first one. And then repeat this row again, this column on the right. 2 times 1, 15 times 1, and so 2 plus 15 makes 17. Okay, now put a little equals if you would, and let's go on back here. And I'm going to look at my table. I have it handy. And notice this basically goes in cycles of 27, as you can see. So 26 letters in the alphabet, and then plus 1 for a space. And basically, you could see 0 through 26 is the first cycle, and then potentially you're going to get numbers larger than that, so 27 through 53, 54 through 80. Theoretically, this can keep going and going and going, and also it works backwards as well. So I gave you some numbers to look at. Hopefully, you won't get anything outside this table. If you do, just know that it works in cycles of 27. So you can either add or subtract 27 to kind of get back in this particular table of numbers. Well, anyway, it looks like the 32nd value, let's see, is going to be E. So this would be E right here. And the 17th value looks to be Q. So now when I encode this message, it changed from BO to EQ. Let's do at least one together, and then maybe you'll do one on your own, whatever the case may be. But let's kind of go through that next piece. So 21 and 12. I'm going to multiply it into my encoding matrix, so 1, 1, 2, 1. Put a little equals there. And let's see what we have, everyone. So I have 21 times 1 and 12 times 2. So it looks like I have 21 and 24 added together. Again, 21 from here, 24 from here, and it looks like 45 would do. I repeat the process, of course, on the next. So same row, right column though, 21 times 1 and 12 times 1. And it looks like if we do that, we get 33. So the next two letters, they were U and L, end up being, in this particular case, it looks like the 45th letter is R, as I see it, and the 33rd in our scale here seems to be F. So R and F. So right now, we're at EQRF encoded. Perfect. Again, I don't have any problems doing a couple others here. You could maybe beat me to it at this stage if you want, but I'll do the 4 and the 5, and then I'll even do the 18 and the 0 there. So if this was a class kind of working together, I'd probably split this up at this point, but whatever, again, I don't mind. So let's see what we have. 4 times 1, 5 times 2, 4 and 10 make 14. So that first number is 14. And then 4 times 1 and 5 times 1. So 4 plus 5 should give us 9. So 14 and 9 in this case. And looks like it's N and I. Okay, looks great. One more. So I'm going to apply that 18 and 0 coming in. 1, 1, 2, 1. It's looking great. Same deal. So when I multiply a 1 by 2 into the 2 by 2, I get my 1 by 2. And so you can see I'm just changing the values, which obviously would change the letters from Boulder to something encrypted. And so let's see what we get here. 18 times 1 and 0 times 2. Looks like you end up getting 18 as a result. And then same premise, 18 times 1, 0 times 1, and so another 18. And there we have it. All right, I did the whole thing. That's great. Hopefully you helped me out a little bit and you're feeling pretty confident with how we encoded it. But basically, this would be the case. I would send you this message right here, EQRF, and then NIRR. Obviously, you would receive that message, and you wouldn't know what it meant until you had a chance to decode it. If somebody else intercepted this message, obviously it would mean nothing as it's been encrypted. Since they don't know how it was encoded, they would have no way of decoding it. And so now we kind of go back. This was the one prospect right here of encoding a message. Now what we're going to want to do is decode a message. And so think logically for a moment just about how we pulled this off, and then think how we can undo exactly what we did right there. If I used this matrix A as a product, well, as part of the product, I should say. In each case, here we go, 1, 2, 3, 4 times. How can I reverse the process? What would the decoding matrix look like? And if you think about it for a moment, I'm hoping you would agree with me that the inverse would probably be the best course of action. So by multiplying it into matrix A, we encoded it. By multiplying it, the encrypted message into the inverse, we should decode it. And that's exactly how we're going to do it here. So I think it would be a good idea just in this case. Let's see if we can find a touch of room. I'm going to do it right here. So the decoding matrix, little review from the previous lesson, so not a bad idea. So I have a 1, 1, 2, and 1, just evaluating that determinant. And then times this piece right here, remember, switch the main diagonal, so the 1 and 1 obviously stay. And then -1 and -2, so change the signs on the secondary diagonal. So everyone, you're more than welcome to pause the video at this stage and find the inverse, and I'll get it as well here. Otherwise, you can just play it out with me. So I end up getting 1 over, and it looks like the determinant here is 1 minus 2, so a -1. And same premise, everyone. Going to take that and distribute it into the modified matrix right here, and let's see how that works. So I do 1 divided by -1, that's -1. -1 divided by -1 is 1. -2 divided by -1 is 2. And 1 divided by -1 is -1. And everybody, that should be our inverse. So what we're going to do at this stage is use these two pieces right here. I send you this message. You have no idea what it means. But because you know how it was encoded, you now found how to decode it. And that's this piece right here. And so you would look at this, and you would start with E and Q, and you would go backwards. Let's just do 1 just to see that it would work. And then from there, you can either do the rest, or we can go on to the next problem. So here's what I would do. I receive this message, and I see E and Q, and I know my table of values. And so E, according to my table of values, you could choose any number, but it looks like 5 is probably the best to use for that. So I'm going to do a 5. And then I find Q, and Q would be the 17. So I do 5 and 17. And then what I'm going to go ahead and do now is multiply that into my decoding matrix. So -1, 1, 2, and -1. And let's see what we end up getting here. Shouldn't come as a great shock. But again, I would receive this. E and Q, I know as these two numbers right here. And if I want to decode it, I will multiply it into the inverse and figure it out. So I get 5 times -1, which is -5. 17 times 2 is 34. And -5 and 34 make 29. Let's do it one more time, and then we'll check letters. 5 times 1 is 5. 17 times -1 is -17. 5 and -17 should be -12. And then if I go to my table there, sorry, I'm going to have to come right down here. But as you can see, number 29 on my table is definitely B. And -12 on my table is definitely O. And I'm just going to go ahead and put a ... right here. I ran out of boardroom. I think that should suffice. But you could see, obviously, just verbally, let's go through this. Excuse me. If you were to do the same thing on these two, find two numbers from the table and multiply it into the decoding matrix, you should get two letters that match up to U and L. Here, again, you'd get D and E. And here, everyone, you would, of course, get R and the space. Good? Here, let's go on to example 2. So example 2, it says, decode the following word. It was encoded with the same matrix from example 1. So how about this? Let's first of all put in as the inverse. If it was encoded the same way, then the inverse is the decoding matrix. And so we get this piece right here. And then what you want to do is set up these 4 letters. Let's go ahead and I'm going to just get you going on this piece. These 4 letters, let's go ahead in pairs, of course. And so first order of business would be O and N. And so I have O is 15 and N is 14. And you're going to multiply that into the decoding matrix right here. Figure out what the two numbers are. and match them up. And then same thing, I and A. I would do that right here, everybody. I is 9. A, of course, 1 would do the trick. And I've got -1, 1, 2, and -1. Multiply it into that decoding matrix right there, and you should get the other two letters. So I encoded it with the same matrix that I did from example 1, so obviously it's the same decoding matrix to see what happened. Well, everyone pause the video for a moment, see if you can pull off the 4 letters here. I kind of walked you through hand in hand for the most part, but see if you can work that out. Okay, so let's see how you did. Not the most profound of messages, excuse me, but seems to be math. Nice, easy 4 letters, works perfectly. All right, good. So you kind of see that prospect right there of working through. Now, again, if this was a typical class, I would probably stop at this point and get partners going and working on this long one right here. So I would ask you if you have the time and inclination to kind of work through this. I will not make it mandatory, but it is a good one to look at. It was meant to be not a trivia problem per se, but it was something that you would have to provide an answer for. So you would go ahead and give me a long decoded message right here, and it would tell you to do something, and you would go ahead and answer the decoded message. So at the very least, kind of start it out. And if you want to do part of it and ask what the rest of it is, that's perfectly fine by me. But I will tell you how I encoded it. At the very, very least, see what the decoding matrix would be, and maybe start out a few, just kind of get your bearings on it. It should make pretty good sense, so it's kind of start at the front. And if you're getting a whole bunch of nothingness, then obviously you made a mistake somewhere. So please get a little practice here. I think it is important to at least do that piece. I've seen students over the years do this pretty well, but just you can see a little arithmetic mistake, it's going to ruin the whole thing. So try to perfect it if you can. Okay, well, long story short, here's how I encoded it. This was my matrix A, 3, 1, 2, and 1. So take a moment, again, at the very least, find what would be the decoding matrix and at least do several of those, get a bearing for it, make sure it makes decent sense. And if you want to do the whole message, that's great. I would encourage you. As you go through this, please don't hesitate to ask questions. If you get stuff that's wrong, I'm pretty good about just seeing where it went astray and how to fix it. So this is a relatively short lesson today. There should be at least a problem to decode on the homework or two, and at least a problem or two on the homework, and maybe even on the take-home quiz. So take a look, and then there'll definitely be one on the next assessment. Alrighty, well, thanks again for listening.